Okay, so we got up to this question here where it says find the exact value of the gradient of the tangent to the curve at the point where x is pi on 4. Okay, what do we need to do in this question? Okay, find m, and how do you do that? Differentiate. So we know when it says gradient of the tangent to the curve, this means differentiate. Okay, so that's really important that we interpret that phrase correctly. So, we're looking at this. What do we need to identify for this equation as we differentiate it? What do you have? Sorry? I can't sum in the x value. I'll need to do that right at the end. Okay, once I've got gradient. So how do I differentiate y equals x squared sine x? Product rule. Okay, so it's really important that we identify this is a product and we need to use our product rule. Okay, so start by writing a list. As soon as you identify product or quotient rule, you should just be on autopilot, right? Write u, write v, write u dash, write v dash, or du on dx and dv on dx. So I'll write the product rule, and I'll put it over here, as it is on the formula sheet. Okay, I recommend that you've got your formula sheet out each lesson, particularly now as we do calculus, we're using a lot of the formulas that are on the sheet. Not to say that you don't remember them. I think you'll find it helpful to remember the processes, but good backup. Okay, and you want to understand how to interpret it from there. It does look a bit complicated when you're not familiar with it. So I'm hoping that you're ahead of me. So just to clarify, if you did sub in pi on 4 originally, you'd come up with a constant. So when you differentiate that, that would become 0. So it doesn't make sense to do that, right? We always substitute after we have the gradients. And I'm going to write it as m equals, it's y dash, y on dx, whatever you like. So u times dv on dx. Plus v times du on dx. I'm just going to write that as 2x sine x rather than sine x 2x. Please don't be confused and think that you can put that 2x in with the x. That sign, the x, sorry, is attached to the sign. Okay. You could think of it as a bracket there if you like. Okay. Alrighty. So now what do we do? Now we sub in. Okay, I probably wouldn't worry so much about tidying up as well. Not that there's anything I would particularly do here when you're going to substitute in, because often the calculator will sort that out. Although, in this case, what does the question ask us for? Exact value. Okay, so that means, unfortunately, we can't just put it in the calculator, and we might have to play around with it a little bit. Okay, so we've got pi on 4 squared. Remember, the whole fraction is squared. You're squaring the numerator and the denominator. Okay. Cos pi on 4 plus two times pi on 4 and sine pi on 4. This answer is not going to be acceptable. We have to make it more simple than this, right? What's pi on 4 squared?
Pi squared over 16.
Okay, so square the top and square the bottom. How do we work out cos pi on 4? Triangle, right? That's cos which is
1 over the square root of 2.
And I mean, you might find that you remember. I do remember those ones because it's only one of them. Okay. So that's 1 on root 2. Remember, we're multiplying here. Okay, just take a little bit of care. There's like a funny sector graph that's like about mistakes students make in calculus, and it's like this big that's like errors using calculus, and then the rest is algebraic errors or numerical errors, arithmetic errors, something like that. So it's really easy to make silly mistakes just from your fractions, simplifying, etc. Okay, so here 2 pi on 4, that's going to become pi on 2. And sine pi on 4 is also 1 on root 2, right? Now, what do I notice that I'm going to have to sort out?
Denominator is square root of 2.
Yeah, so it is expected that we will rationalize the denominator. Okay, look, if this question was worth 2 marks, probably you should be okay to just kind of put those fractions together. It feels a bit too much work to rationalize for 2 marks, but
Bless you.
if it was worth any more than that, I think definitely need to, and it's kind of our expectation. Okay, so I'm multiplying top and bottom by root 2, so that becomes root 2 on 2 and root 2 on 2. And I can just simplify a little bit more. I mean, there are a number of ways that you could leave this answer. Can you just put the scissors away? No? Okay. So here I can have root 2 pi squared on, that's going to become 32, plus root 2 pi on 4. Okay. And then maybe I'll make a single fraction. You can factorize here because you can take root 2 pi out of both of them, but is that necessary? No, you haven't been asked to factorize. It's not necessarily more simple, it's just different. So are we happy that I've multiplied top and bottom by 8 there just to make a common denominator? So that's going to be 8 root 2 pi, and then it's all over 32. If you did factorize, which as I said is not necessary, you'd take out root 2 pi, you'd be left with pi, you'd be left with 8, and you could put the over 32 anywhere really. Bench.
Just a question. I times the 2 fractions together first, and then I times the denominator by square root of 2. Is that okay? I got the same answer.
Same.
Okay, cool.
Okay, so that's the gradient. Now, we're not asked to do anything with that, so we're finished, but always make sure that you've actually answered the question. Okay? Alright, this question, not at all difficult, but may feel more difficult than it is because usually we differentiate with respect to x, but this time it's t. It's the same, okay, but you're at t instead of x. So have a go, and then I'll follow behind you. Maybe this one people might be a bit unsure, but remember, you're treating everything except t as a constant. So imagine if that a was a constant, what would you do? That might help you.
Bless you. Bless you.
Sine differentiates to cos. That's it. I did it on purpose. Just be careful. Remember that cos differentiates to negative sign. differentiate what's inside the bracket there, okay, which is referred to as your f of x on your formula sheet. We multiply by that, so we differentiate pi t to get pi, multiply by that, cos becomes negative sign, and we keep our f of x the same. I'll differentiate first. You could simplify first, but we will be able to simplify this. We won't leave that negative t inside the bracket, pretty much. Would you lose a mark? I don't think so, but it might make things easier for you in a question where we were applying this, but we'll talk about it as we do it. So I differentiate negative t and I get negative 1 times the negative already, and cos differentiates to
negative sign.
Could you put this as just literally away, maybe to avoid the temptation? Thanks. Okay, so we've got 3 negatives here. And so what does that become?
Negative sign of negative t.
Okay, negative sign of negative t. I might just do it here. Okay, but we talked about this last lesson as well. So sine of negative t, like it is quite helpful to know for sine and cos. So it will work for any angle, but if we just focus on the acute situation, if this is angle t here, okay, then negative t would be down in this quadrant, okay? And so sine of negative t, we would rewrite this by looking at it and going, okay, it's sine, and in this quadrant sine is negative, okay? I'll come back to that in a moment because there's another negative, it makes it a bit confusing. So I would go, okay, it's going to be negative because we're in this quadrant, then I change my angle to that acute angle, which is t. Okay, that's our normal process when we're working with trig in our ASTC, right? So sine of negative t is the same as negative sine t. Okay, helpful to know. So this is already negative, and then I can write sine of negative t as negative sine t, and so this is just equal to sine t. Yeah. Okay. This one here. You're allowed to do that.
Oh, okay.
Okay. Anyone want to have a go at dealing with the a? What do we do? Treat it like a constant. Okay, so how does that look when we differentiate here? Okay, so Dan said we're differentiating AT, okay, which becomes A, and then sine differentiates to cos, and so we have this. You don't have to put the brackets in. It can make it feel clearer. Okay. Cosat. A cosat. Okay, so you can just think to yourself, if you're unsure, what if it was sine 3t? What would you do? You differentiate 3t and you'd get 3, and then you'd have cos 3t. Then just go back and replace the 3 with an a. Okay? So it's something that tends to really put people off when you've got another letter in there. Okay? But if we're differentiating with respect to t, we treat every other letter as a constant. Sorry, did you have a question?
No, it's okay.
Okay. Alrighty, this one here. Differentiate. What do we have to notice? Okay, excellent. You are very good at noticing these things because often people will just differentiate the top, differentiate the bottom, which is totally wrong. Okay? So start by writing your list of U and V. Alright, the quotient rule as it is on your formula sheet. out in a gigantic form for our room once we're back in it, huh? Save me writing it all the time. So first thing that you do, product rule or quotient rule, you're writing a list. U equals V equals U dash equals V dash equals. Okay, that's your standard that you start yourself on. Okay? Then you're looking at your formula sheet, or maybe you know the quotient rule, it really doesn't matter. If you're looking ahead, 3A is the same as this one, so I've corrected that now. I put it back on, but I put the, oh no, I didn't.
So is the bottom of V and the top U?
Yes, so you can tell because on your formula sheet it tells you that y equals u over v is on the formula sheet. Okay, so it does tell you the position, u on the top, v on the bottom. So, following your formula, you've got f dash of x is v du on dx. So, I'm just going to write it in the other order. Okay, really important that we can't change this into a cos squared. Okay, because that expression that's attached to cos is different. Okay, so it needs to stay like that. And then minus, and we've got u dv on dx. Now, notice we've got minus and then minus, so I'll turn that into a plus. And then sine 3x minus 1 sine x, or sine x sine 3x minus 1. It's the same thing, right? Okay, you kind of feel like this is extension-wise, we've got the cos, sine, right? Except that this 3 does muck things up a bit because we don't have it over there, if you were thinking that. So, I'm just going to stop right there. Oh, no, wait, sorry. Finish the quotient rule. Oh, my goodness. Okay, don't forget V squared. And actually, we probably will tidy this. I mean, you could leave it here, and I think you'd be right. But you can see if we separate it into two fractions. I don't really want to write it as two separate fractions because it's kind of annoying. But if we look at this over cos squared x and this over cos squared x, we can cancel out a cos and a... I'll just write it. It'll be clearer for you. Okay, so this is not necessary for you to write. This is so you can see clearly. I can see clearly now. There was no rain. Okay.
Yeah.
So now we can cancel out cos x and a cos x there. Please make sure, like I said before, you need this expression that's attached to cos to be the same for you to be able to do that, okay? So over here, I'm going to be a little bit sneaky maybe. Sorry, Dan. No, so I've got sine over cos squared.
We get
Yeah, so I'm going to write it as sine over cos is tan, and then keep a cos x. Does that seem okay? So what I have there, it's mostly because now I've got common denominator as well. Don't be so stressed about this, okay? But in terms of if we were asked to show in those questions, good skills for us to be able to see. We've got sine x over, I'm going to write cos squared x as cos x. Cos x, yeah? And we know that sine x over cos x is equal to tan x. Yeah? Now tan x means tan x as a numerator, so I'm left with tan x over cos x, which is what I've done here. Okay? And so now, I mean, it's still not particularly good looking. Sorry. No? So, and then I'll put it all over cos x. Don't go trying to cancel cos 3x minus 1 and cos x or anything. Okay, I'm just going to leave it there. Okay, so that one I have changed the slide because you'll notice that that first question there is the same as the one we just did. Okay? So you can have a go at differentiating those two. So you go ahead. Not sure if you're a bit rusty on differentiating e to the x. Do you remember what that differentiates to? Itself. That's one of the really amazing things about e to the x. That's why e is e, right? Yeah.
No, because it's still cot. It's still cot over sine, right?
I know that. That's why I have to
It's still just as complicated as e to the x sine x minus cos x.
I think though that it's up to region because most of the time it's going to be that you're doing something.
You can use like auxiliary angle and stuff for some of them. I've known.
Okay, so make sure you use your rules. So really big mistake that people make with these questions is they don't identify it as a product or a quotient. Okay? So you're doing a really good job of identifying that. Then you write your list, sub into the formula. Don't be a rookie and forget over v squared. I would never do that. Well, I didn't forget, did I? I got it in the end. Hopefully you look and think it looks a bit simple for a quotient rule. So we've got v du on dx. So I'm going to write that just as e to the x sine x minus u dv on dx, e to the x cos x, all over v squared. And remember we write that as sine squared x. It's not the x that's squared, it's the sine x, which we write as sine squared x. Can you leave it here? Like, you can. How far do you need to go? Let's tidy it up a little bit, okay? Because we can see some similar things to before, or to the previous question. So, how I simplify this, like honestly, is going to be in this case directed by the fact that I've got sine x as the denominator of my other fraction. So I'm going to try and make them both sine x. Because you can write this, you can think of it in different ways depending on what suits you at the time. So I'm going to do very similar to what we did before, right? So this is cos x over sine x and cos over sine is cot. So we're going to write this as cot x over sine x. Okay. I'm going to take the e to the x out. You don't have to factorize unless it's specified, but it just kind of feels so nice to take it out. What happens when you take out e to the x from here? Are you left with nothing? No, so you have to have your 1 there. That's really important. Okay, so watch out for that. Okay, what does CSC mean? Cosec. Awesome. Okay, so hopefully you've started on this one. Go ahead if you haven't. Wait a minute. I don't have a rule for differentiating. I'm looking, I don't have a cosec x rule.
You just change it to 1 over
Oh, okay, so cosec is actually 1 over sine. So, no, our response should not be get rid of the question. It's a terrible response, okay? Our response is actually, wait a minute, this is what? This is a quotient, and it's exactly, magically, we just know, it's the same. Oh wait, alright, draw the arrow up that way, huh? Same. Oh dear, okay.
Do we have to do
Well,
it
how
again?
did you differentiate cosec x?
No, I did get it right. Because I forgot to change cosec to sine when it's on the bottom.
Okay. So, can everyone see that? When you're presented with something that's a little bit different, you have to stop and think, this wasn't really difficult, but don't leave the question. Think to yourself, okay, I don't know how to differentiate cosec. What do I know about cosec? I have to write it in a different way. It shouldn't be much of a stretch to think, oh, I write that as 1 over sine. Yeah? Okay, we're obviously not going to redo the question when we've just done it there. Well, if you'd like to do that, you feel